Welcome to this study guide on depreciation methods. We will cover the straight line, double declining balance, and sum of years digits schedules. First, let's define the key variables used in depreciation calculations. C is the initial cost. S is the salvage value. N is the useful life in years. BVT is the book value at the end of year T, and DT is the depreciation amount in year T. The straight line, or SL method, is the simplest and most common. It spreads the asset's cost equally over its useful life, resulting in a constant annual depreciation expense until the salvage value is reached. The annual depreciation, D, is calculated as C minus S divided by N. The double declining balance, or DDB method, is an accelerated approach that counts twice as much depreciation each year compared to the straight line method. The rate is calculated as 2 over N. The depreciation amount DT is calculated by multiplying the rate by the previous year's book value. Remember that the book value cannot fall below the salvage value, and depreciation must be capped in the final years to meet this constraint. The sum of years digits, or SOYD, is another accelerated method. First, calculate the sum of digits, or SYD, using the formula n times n plus 1 divided by 2. Then, calculate the depreciation amount DT using the formula C minus S times the remaining life divided by the SYD. Let's review our first example problem. A machine costs $60,000, has a $6,000 salvage value, and a 6-year useful life. We need to determine the SL and DDB schedules. For the straight line schedule, the annual depreciation is calculated as $60,000 minus $6,000 divided by 6, which equals $9,000 per year. As you can see, the depreciation expense is constant for all 6 years, resulting in a book value of $6,000 at the end of year 6. For the DDB schedule, the rate is 2 over 6, or 33.33%. Notice how the depreciation expense is much higher in the initial years. In year 6, the standard calculation would drop the book value below the $6,000 salvage value, so the depreciation is capped to ensure the ending book value equals $6,000. In example problem 2, a firm purchased a machine for $30,000. It has a useful life of 4 years and no salvage value. We will compute the SL, SOYD, and DDB schedules. The straight line depreciation is calculated as $30,000 minus $0 divided by 4, which is $7,500 per year. The schedule shows a constant depreciation expense, resulting in a $0 book value at the end of year 4. For the SOYD schedule, the sum of digits is 4 times 4 plus 1 divided by 2, which equals 10. The depreciable base is $30,000. The schedule applies the fraction of remaining life to the depreciable base each year, resulting in a $0 book value at the end of year 4. The DDB rate is 2 over 4, or 50%. The schedule shows that the book value is entirely written off in year 4 to reach the $0 salvage value, as stipulated by the problem conditions.